Okay, here we go. It must be Energy Day. Why? Because it's Wednesday. Wednesday is energy. And this is Hawaii, the state of clean energy, every Wednesday, 4 to 5 p.m. here on ThinkTech Talks. And today our principal discussion is going to be hydrogen for Hawaii, especially Hawaii transportation, with Stan Osserman, who is with PCAT, make that HCAT, the Hawaii Center for Advanced Transportation Technology. Did I get it right?
You got it right.
Thank you. And my co-host, Ray Starling from Hawaii Energy. And cool man. Okay, and we're going to have our nanowatt, negawatt moment.
Megawatt.
Thank you for that. Courtesy Rob DeVeraterra, who set this up. Thank you, Rob. He's from Hawaii Energy also. And we have on Skype, and you can see him in a moment, David Moss with People Power in Palo Alto. And if you say that fast, it sounds like People Power in Palo Alto.
Hi there.
Hi there. So David, here on the Negawatt Moment, you're doing a pilot program for People Power in the form of an app. And God, there's apps everywhere, isn't it?
There are.
It hasn't passed you by. So tell us about the pilot program.
Yeah, so People Power has a really cool technology. We are funded through the Energy Accelerator program here in Hawaii, and working in conjunction with Hawaii Energy, the ratepayer-funded conservation and energy efficiency program. We are rolling out to 600 to 1,000 homes a smart home technology that will help you save money on your electric bill.
Oh. Okay, we can't hear you, David.
Ah.
Now we can hear you.
Okay, there we go.
I don't know what that's about. It could be science, or it could be something very mystical.
It's the internet, right?
Must be. It's an
All right,
art, not a science, yeah.
Yeah, so I don't know what you caught there, but we're funded through the Energy Accelerator. We're working in conjunction with Hawaii Energy, and we're rolling out smart home technology to 600 to 1,000 homes in Oahu.
Why?
We can save people money on their electric bill. So we have an app called Presence, and Presence will enable you to control your home remotely right from an app. You can turn things on and off. You can see how much you're spending. Connect with the community around you. And what's really cool about Presence is it actually will recycle old smartphones and old tablets into free Wi-Fi and cellular video cameras.
We lost you again. But that's very interesting. Maybe you can step in a little, Ray, and tell us until we get some sound from David again. It must be Palo Alto. Maybe you have a bad wire in Palo Alto. What do you think? Can you hear me?
I can hear you, yes.
Now I can hear you.
Yeah.
Time delay.
I think it's time to go down to Best Buy and get another microphone.
I think so, huh?
Okay, well, keep talking.
Yeah, so you want to see the app?
Yeah.
Let me show you. So this is an app called Presence. You can download it off the App Store, and it's available on iOS and on Android. And inside of Presence, right here, you can actually see how much my home is consuming on electricity. And this is something I've added onto Presence with my own account. And then in addition to that, I can actually control the appliances in my house. So you see this light back here? I can actually control that right here from the app and turn it on and off and see how much it's costing me. So this is how we can actually save people money. And also by connecting you with the people around you, we can get people to share their energy efficiency tips and help you save energy on your electric bill. So we are looking for 600 to 1,000 homes who want to sign up for about $300 worth of free smart home technology, including this type of smart plug. You plug this into the wall, and you plug something into it that you want to monitor and control remotely. You can go to oahu.presencepro.com to sign up.
Oahu.presencepro.com.
That's right.
Okay.
Yeah.
Now let me ask you some questions that come to mind. And Stan, you know, we expect you to join in on the Q&A here. Okay.
Okay.
And put you aware of that. And sometimes we want hot questions, eh? You know, like cross-examination.
Okay.
Okay. So first question is, can I do this from Albania?
You can. You can do this from anywhere in the world. Yes.
And all I need really is this this gizmo that plugs between the wall outlet and the appliance. And I guess I need some kind of wireless in the house to connect it to the internet.
That's right. You need a Wi-Fi access point, and then a modern kind of Android or iPhone or iPad kind of smartphone device, and you can control this from anywhere. You can also control it from a browser.
Fabulous. And so I guess the real delivery point here is that not only can I turn things on and off, which I think other entrepreneurs have rolled out products that can do that, but I can see how much energy I'm using, so I can make intelligent decisions about whether to turn things on and off. Yeah.
That's right. And you can set rules. So you can say, for example, I have a bunch of rules here. And if I turn and tap into my rules for my light, you'll see, for example, if I go away, then make my light switch off. That could be your air conditioning, your entertainment center. You can make it shut off automatically at certain times of day, like while you sleep. And you can just automatically be saving money. Now, another cool part of this app is it's not just centered around energy. It also has this really cool video camera function in it. And this works on iOS devices especially. So you'll see here, I have just turned my iPad into a camera. And where you see the green squares on the screen, that's where it's detecting motion. So as motion is detected, I can actually record a video with this app presence, and you'll get notified on your cell phone. So you can know when something is happening inside of your house, and then you can actually control the home itself with these types of smart plugs.
So that's a security alarm system. That's a burglar alarm. Yeah?
That's right. It's combining security with energy.
Oh, that's fabulous.
Well,
Just like you're there.
Speaking of security, is it encrypted, or do you have good security on the connections and things?
Absolutely, yeah. It's all bidirectionally encrypted, authenticated, and a bunch of security stuff on our server side as well. We take that actually very seriously because the utilities we work with have certain requirements for security.
Okay, Ray, questions?
I can't hear in my earpiece, so
you can ask a question.
I have heard parts of it. When do you expect to deploy this?
So we're going
Hawaii?
to start rolling out the hardware and the actual program that wraps around this in late July. So we are taking signups now, and again, it's at oahu.presencepro.com. And once we have all of our signups complete, then all of this stuff will be getting rolled out. And what we're asking for in return is we want to see some of the energy data coming off of these devices and the whole home meter, so that we know that our program is effective.
Can we use this in a commercial location or only residential?
Yes, we are accepting businesses, and in fact, I think businesses tend to spend a lot more money than homes. But everybody has an electric bill to pay.
So one other thing is, okay, $300 worth of software. Let's assume for this discussion that it's $300 ultimately.
Yeah.
Which sounds like that wouldn't be too far off actually. But if you're going to charge extra for the devices, right, between the wall and the appliances. How much do they go for? And what is there a monthly charge on all this?
So there is no monthly charge. In fact, the cool part is that since we are funded by one of Hawaii's startup accelerator programs, the Energy Accelerator, this equipment is basically given to participants for free. So the participants who actually sign in will receive free hardware like this and free premium software on top of that. Now, in our software, there are some optional upgrades which people do all over the world today when they download this free app Presence and they turn their old devices into cameras. You can optionally upgrade it to get more cloud video storage and things like that. But for this program, it's all really baked in for free, which is pretty awesome for people who sign up.
Well, when it rolls out into the market, will it still be, just the price of buying the app in the first place, nothing more? I guess you get the equipment, but then
right.
Is there a monthly charge?
So our monthly charges are actually, so let me describe our business model a little bit. We're actually, this is a pilot and we are trying to discover and validate more of a service provider strategy, where actually we have other service providers who are paying for these types of services on behalf of their customer base, so that they can engage with their customers and really meet their goals and mandates. So Hawaii is one place where this is getting rolled out. We're also rolling this out in Cape Cod, Massachusetts, and then parts of Canada as well.
Well, that sounds terrific. My last question is, can you take my registration over the phone?
We'll set
Sure,
you
I
up.
can make that work. Yeah, but go to oahu.presencepro.com and you can sign up. And we really appreciate Hawaii Energy's support on this and the support of the Energy Accelerator in Hawaii. I think this is a fantastic program for residents on Oahu. Will really help you save money on your electric bill, which everybody needs.
Well, that's great. It puts you there, and it puts you there with a certain amount of leverage, of power, no pun intended. Thank you,
Yeah.
David Moss. People Power in Palo Alto with his
Thank you very
pilot
much.
program. Thanks so much.
All right, take care.
Take care. Wow, I'm ready for break. What do you say, Ray?
Sounds good.
Stan?
Good for me.
Let's have a break.
All right.
That's Stan Osserman of Hawaii Center for Advanced Transportation Technology, and Ray Starling, my co-host from Hawaii Energy. And we're talking about hydrogen for Hawaii. We're going to talk about that more seriously right after this break.
Hello, I'm Martin Despang, and I'm the host together with the one and only Ali Yamashita, and our show is called Urban Transcendence. And Urban Transcendence is about identifying where we have a unique situation of a vibrant city in one of the most beautiful natural environments. So how these two can coincide, sometimes conflict, how they could find reciprocity in the 21st century is what we're excited about. And we're planning on bringing in a diverse body of guests, both from the arts and the science and the established and the wise and the emerging generation. So hope you will join us. We'll always be on Thursdays from 1 to 2 p.m.
I'll hang in, yeah.
Okay,
I'll turn
we're
off the
back.
videos.
We're live. We're here. Hawaii, the state of clean energy on Wednesday. We talk about hydrogen for Hawaii with Stan Osserman from HCAT and Ray Starling from Hawaii Energy, my co-host. And so to get the show on the road, you issued a press release, didn't you, Stan? Admit it.
No, I didn't do it. Yes, we sent out a press release this morning from one of our contractors, US Hybrid. They're based out of Los Angeles, California, in Torrance. And they do a lot of our conversions of our vehicles out at Hickam that we convert for the Air Force to demonstrate hydrogen technology. But what they're doing that's neat about this project is they just purchased a 25-passenger bus that they're converting for the Mass Transit Authority on the Big Island. So this is really the first time we've rolled out for a county or a state entity in Hawaii a hydrogen vehicle that's going to be used in mass transit. So it's kind of a big deal for us.
It's a big deal on the Big Island. I mean, I remember, Billy Kenoi, when his term first started, the mayor there, he was offering, and his predecessor too, he was offering free bus service on the Big Island.
They still do.
Still do.
Yes.
That's really a nice thing in many ways, but mostly in the way of allowing people who can't afford or shouldn't afford to drive a car from Hilo side to Kona side for a job in the hotels, they get free bus service. This is a blessing, really, to do this. And so, the Big Island is really special about buses, and maybe the bus we're talking about will be deployed, on that route, which will make it famous.
Well, we're hoping that we'll actually step out with more hydrogen transportation in the MTA on the Big Island in the next few years. We're working with several folks, including the Department of Energy, and some folks on the Big Island, some landowners, some farmers, and folks that have an interest in advancing hydrogen throughout the infrastructure to put some hydrogen mass transit on the Big Island. In addition, our shop is doing 2 hydrogen fuel cell buses for Volcano National Park. Those buses are almost complete in our shop right now. They'll be deployed, and HNEI up at the University of Hawaii is working with us on that project, and they're going to be providing hydrogen and tube trailers to move the hydrogen around on the Big Island. So
they're going to get the hydrogen from the geothermal, Puna geothermal?
Don't say that.
Oh, sorry. Okay.
No, there's actually they're still working with Puna geothermal to produce hydrogen, but they're looking at a lot of renewable energy sources.
Oh.
The whole key here is to use renewable energy, because when you use the renewable energy with the hydrogen, it's clean all the way through. There's no hydrocarbons, because all you're doing is splitting a water molecule in half using renewables, and if you do that without carbon footprint, you're not making any pollution. When you put it back in the fuel cell, the hydrogen meets with the oxygen in the air and generates electric current, drives your motors, charges your batteries. It's another kind of electric vehicle, just like plug-in electric vehicles.
So why is it that all we hear about is buses? Why don't we hear about cars?
We do hear about cars, but...
Maybe we could hear about them now.
Okay, we'll talk a little bit about them. Our office works a lot with the auto manufacturers. About 2.5, 3 weeks ago, Hyundai rolled the first hydrogen fuel cell vehicles off the ships in California. California has hydrogen dispensing stations. Not too many of them, but they're getting upwards over a dozen right now. And Hyundai is leasing their cars for right around $500 a month, but it includes the hydrogen for the vehicles.
Oh, really? Wow.
So that's being rolled out right now. Toyota, Honda, Mercedes-Benz, BMW are all in the production mode for hydrogen fuel cell vehicles. Most of them are being deployed in Europe, a few in Canada and on the East Coast, and then California. We're trying to get Hawaii in that list as well. And part of it's just timing. I think the last time we talked, you were a little frustrated, and so was Sharon, about not having hydrogen fuel cell vehicles here sooner. But the good news is the legislature this year renewed the barrel tax. So there is funding available in the year for projects that benefit Hawaii and renewable energy. We're looking to tap into some of those resources over the next couple of years because they renewed it out to 2030. And trying to stand up infrastructure here that will slowly bring in vehicles. And I think it's unreasonable to think that you'll get a whole fleet of hydrogen vehicles here at once. But they can be scaled. The hydrogen production and dispensing can be scaled. So we're going to start working with the Hawaii Auto Dealers Association and the folks in the automobile side of the house. And we're going to start building some infrastructure for them so that they can refuel those vehicles. We're working with the city and county. The same company that we did the press release on this morning is looking at doing a trash collection vehicle for the city and county of Honolulu. And they'll be running that one once that project is done. Again, we have all the vehicles out at Hickam that we do.
They've been out there for a while.
But we've got more coming.
Oh, okay.
We actually, right now we have a refueling vehicle and a crew bus, but we're supposed to be getting a missile loader for F-22s out of the Hawaii Air Guard. And we're also going to be getting a tow vehicle for the C-17, the large cargo aircraft, and also a vehicle we call Secure Power on Demand, which is a big bread van, a UPS FedEx-sized truck that has enough internal power capacity to plug into a small building and run a command post or a small building for a pretty significant amount of time. So you actually could put power back into a microgrid with these vehicles. So we've got some more vehicles
talk
coming
about
out.
that too. So who's making all these vehicles?
Right now, our prime contractor for our conversions is US Hybrid, the folks that sent out the press release.
Conversion?
Yes.
So you buy a vehicle, an ordinary, conventional, fossil fuel vehicle.
Correct.
And you convert it in your shop on Cook Street
Correct.
there.
That's exactly
you
what
pull
we do.
out all the fossil gear, and you put in this. Well, I guess it's a fuel cell and a battery. And
Fuel cell batteries, controllers, cooling, everything. In fact, if you want a good diesel engine, I got some great deals for you. Because we pulled a bunch of diesel engines out of a bunch of vehicles, and they're sitting in my shop because we're converting vehicles to run off hydrogen.
What I'd like to do, actually, what ThinkTech would like to do, is come down to your shop and make an OC-16 movie of exactly
Outstanding.
how this
We
works,
love it.
you know?
We love it.
And see you remove things and replace them. That's pretty exciting. You know?
It's fun.
So, but the question is, and it goes back to that show with Sharon Moriwaki and me, and that is, is this efficient or is this just a big trial?
I think what you're going to find is, as we go forward in time, you're going to see the plug-in electric vehicles have a place when you have short distances to run, and you can plug in a lot of the stalls that we have available in town. you're going to see internal combustion engines continue to go in some vehicles just because people can't afford the change, and the technology will be, you know, a little bit above average for most people to be able to afford for a while until they're in mass production. Then the cost will come down.
When I came to Hawaii, which is October 1st, 1965, you were just a young person at the time.
But I was already here.
But you were already here. I can figure that. And Ray was too. No.
But the hydrogen vehicles will get
I saw Cadillacs all over the place as cabs, as taxi cabs. And I said to myself, what is this? No place in the country, maybe the world, do they have Cadillacs as taxi cabs. And then I realized what it was. Is Hawaii from early on has this fantastic love affair with cars. And still today, I mean, the huge ratio of cars per capita in this state, and people spend all of their disposable income on those SUVs with the tinted windows. Really expensive, much more than they can afford. And this, of course, congests everybody on the highway. And it's fossil fuel, I'm sorry to say. So do you really think that the population at large is going to make a shift?
Yes.
Because so far, there are only 1,800 electric cars in the state of Hawaii.
But what people I don't think are tracking well, and I think we ought to start looking at the statistics for, is the hybrid electric vehicles. You know, the Prius came out several years ago, plug-in electrics, but then also the hybrid electrics. And now you got Ford Fusion and all the major auto manufacturers are doing hybrid electric vehicles. And like I told you on the last show, I'm happy with every hybrid electric vehicle that comes out, because you're 80% of the way to a fuel cell electric vehicle once you have a hybrid electric vehicle.
Yeah, you intimated a little while ago that the farmers and the ranchers could actually be friends.
They could.
And
they could.
That's from Oklahoma. I'm not going to say
They tell jokes about each other.
Right. So, but you know, okay. So you know, it's like energy in general. We welcome all comers, but some comers are more welcome than others. You know what I mean? So, and that's a true statement. Nobody's going to disagree with that. So the same thing with farmers and ranchers here. I mean, if you had to buy one of them, which one would you buy? Hydrogen or pure electric?
I would probably go with the hydrogen because of the distance I travel every day to come to town. The advantages to a hydrogen vehicle are your range and your fill speed. When you have to replenish your vehicle with energy, a plug-in electric, if you deplete it down too far, it takes a while to charge it back up. Will the battery technology get better? Probably. Will it get cheaper? Maybe not, because there's a lot of rare metals that go into batteries. When you start having to make millions and millions and millions of them, that price isn't going to go down, it's going to go up. So fuel cell storage is a tank. It's pretty basic. It's not
You can fill it right away. You don't have to wait around for hours or anything like that.
Right. The main thing that you do in most of the hydrogen dispensing stations now is control the temperature and the rate of fill to keep the temperature down, and pre-chilling some of the energy that goes in to keep it cool.
To avoid explosions.
No, just to keep it from expanding. That's all. So you can get a good full tank of fuel.
So, you know, the thing about it is that this has a direct relationship with the undersea cable, such as it is. Because, you know, if I'm thinking pursuant to this discussion that we can move hydrogen around, there would be a market to move hydrogen around from island to island in these things that look like scuba tanks or maybe bigger.
Is he a genius or what?
Then why exactly
That's
do we
what he
need an
said.
undersea cable? Oh, maybe we do. Maybe farmers, ranchers, and undersea cables can be friends.
I prefer hydrogen being shipped in containers between islands. I mean, if you have renewable energy, particularly if you have excess capacity, curtailed power, or even dedicated power to producing hydrogen, I think you can get the cost per kilowatt hour down to where you can make a decent argument for hydrogen as a storage medium of energy and hydrogen to be imported between the islands to fulfill. The Big Island has just a huge amount of renewable resources to make energy. So why would you want to string a cable from the Big Island to Honolulu when you could either ship pressurized hydrogen, potentially? I mean, I'm not an expert on liquid hydrogen. There's some issues with liquid hydrogen, but potentially, if you have the right vessels to put it in, move that between islands, get it to Oahu, convert it to gaseous, and dispense it in vehicles. There's a whole lot of people smarter with that technology than myself, so I'm not going to go out on a limb and tell you I know how that works, but it's viable.
You know what though? You're here with HNEI, that they're studying exactly how you make hydrogen, and you're creating, hopefully, with passenger automobiles, you're creating essentially a market for hydrogen, and a system for getting it from one point to another point. Hawaii could be the place where best practices are developed that could be the standard for hydrogen, storage, use, transport, and so forth for the world.
Hawaii should be the place. We have a chance to showcase for the world. And I've approached several auto manufacturers, Honda specifically, about doing ecotourism out here with their vehicles, hydrogen fuel cell powered vehicles, have a test track, do hotels, the whole 9 yards. Bring them in, hand them the keys, let them run around the track, then take their car out on the road.
You heard it here. You heard it on Energy Wednesday. Hawaii, the state of clean energy. Energy tourism.
There you go.
That's what it is. Okay, Ray, have at it.
I got a question about the manufacture of hydrogen. I know you were describing electrolysis, and that's tried and true, been around for a while. Is there, and I know that's very energy intensive on the input side, and I was wondering what is being done now to try to improve the ability to get hydrogen from the environment, from water or whatever process you're using to try to make the hydrogen.
Okay. Well, as you know, there's a lot of different ways to get hydrogen, because hydrogen is basically an atomic level particle. It's an atom, and it's one of your your basic elements. It's the first element on the periodic chart. So there's hydrogen in a lot of stuff, and there's a lot of way to get that hydrogen out of a lot of stuff. The way we're focusing on primarily is using renewable energy with electrolyzers. But there's technology being developed every day that's making less power required. The number that we use based on what the University of Hawaii tells us is 60 to 70 kilowatt hours per kilogram of hydrogen. But just last week I was talking to a manufacturer of a new electrolyzer design that they've reduced the cost of manufacturing the equipment, and also by improving, like putting a ultrasonic vibrator inside that releases the bubbles faster, they produce more hydrogen quickly, and they've got the cost down to between $45 and $50 kilowatt hours per kilogram of hydrogen. So the technology amazes me. I've been in this job a little over a year, and I've seen just technology changes every 6 months that make it cheaper and cheaper. And you don't have to think too far back to how big your cell phone was about 10 years ago, when it was a Motorola that was this big with a big antenna, and had to have a cart to lug it around. That's how technology works. Once you start getting it out there, and the market's there for it, and people will pay for it, then the companies start refining the technology, and faster they spread the cost over more units. It gets cheaper and cheaper. We've already looked at some models. I think I can almost release a study done by the Department of Energy a few months ago. Actually, it was done by Idaho National Labs for Department of Energy, that shows that we can produce hydrogen using grid power and photovoltaics in Kaka'ako for the government on government land, and the price per kilowatt hour or per kilogram of hydrogen was in the $11–12 a kilogram mark.
Wow.
When you start to equate that to gasoline, in my mind, I have a Mini Cooper. I get about 30 miles per gallon. So if I go 3 gallons of gas gets me 90 miles, 1 kilogram of hydrogen will get me about 90 miles. We're talking about $12.
Yeah.
I mean, we're talking about the same price. So we've already got a study right now that shows that if you're creative in how you design your infrastructure, the magic with this plan was the infrastructure included covered parking in Kaka'ako that you can rent out, as well as producing electricity for your hydrogen. So, covered parking with PV on top, premium price for nice shaded parking in Kaka'ako rather than being in a building. Cheaper parking than in a building offsets the price of your hydrogen. So things like that can be done to bring the cost down. And you're right, that's always been the bugaboo. How can you make it efficiently? Electric motor, photovoltaic to battery to electric motor is about as efficient as I think we can get for power. It is, and there's no argument. Like Jay said, when are you going to use a battery power? They're going to be here. They're going to be here in certain applications for a long time. But I don't think they will take over the car market because there's other limitations with them.
Right.
You have to replace them. They're hazardous materials. Right. You have to dispose of them, recycle them. You know, a hydrogen tank lasts a long time. You fill it up, empty it, fill it up, empty it, fill it up, empty it an awful lot, and it doesn't wear out. So for storage, you know, you take those costs and cycle them out a few years, and it actually gets pretty affordable. Mm-hmm. So we've got to look at it long term. It's kind of that cradle to grave look that we've got to look at the entire life cycle cost of the technology and do the analysis on that, not just how many kilowatt hours does it take to make the hydrogen.
Right.
Yeah, just last hour we had George Otta in here. George is a wonderful, elegant guy who's the Director of Planning and Permitting. And he sits on he will be sitting on HCDA in Kaka'ako. And he was talking about vertical PV on the fascia of the buildings. Because they have this technology now, why not use it? Why not make these buildings into PV buildings? Why not?
We have a contractor that we're working with at Hickam on the wind power side that has designs for vertical wind turbines that are built into high-rise buildings because, well, as Ray knows, we're in the aviation business in our previous life. When wind goes around an object, it accelerates. Where best to have a wind production, plant than around where the wind's accelerating. It accelerates moving around high-rise buildings, so put the power production there.
Before we take a break, I just want to get clarified on this. What is it? Electrolysis? Did you call it?
Mm-hmm. Yes.
That seems to be the key in efficiency and the key in actually making the hydrogen. No.
Cleanly. Mm-hmm.
Cleanly. So, yeah. So let's say that I have a photovoltaic cell that is creating electricity on the Big Island, or wind that is creating. I guess it would create kinetic energy, and that would go into electricity. Okay, now I have electricity, and I want to put this electricity into hydrogen, make hydrogen. And I have to use electrolysis to do that. What is electrolysis? So that people would know.
Okay.
They should all know this. I should know this, but I don't know this.
I could give you some real details, but I don't want people calling 911 and getting the fire department to their house when the hydrogen goes off after they've accumulated it in their house. But
don't do this at home.
Essentially what you're doing with electrolysis is you're putting a current, a positive current and a negative current with a curtain between it, for lack of a better term, and a pool of water that the current can flow all the way through. Off of I believe it's the positive input, you'll have oxygen bubbling off of it. Off the negative input, you'll have hydrogen bubbling off as the electricity breaks down the water into oxygen and hydrogen. Mm-hmm. It's pretty much that simple. Now, the equipment, more technical, spacing, all that stuff is critical. Getting the most cells and the most of those things you can in a given stack is all proprietary and things like that. But the bottom line is you're basically applying electricity to water and getting hydrogen and oxygen gases off of the two anode and cathode, the two connection points.
And the side benefit is the oxygen.
Yes.
You can capture that and use it for who knows what.
And in fact, our electrolyzer at Hickam, we ran a few tests where we pulled the oxygen off, pressurized it, had it tested, and it's medical grade oxygen. You can use it for welding, you can put it in a hospital, and we import a lot of oxygen here for medical use, and it's expensive to import. Yeah. So.
Okay, the other question is, okay, now I have the hydrogen, and the hydrogen is the fuel for a fuel cell, and the fuel cell is going to create electricity.
Correct.
And then, you'll save that in the battery under the car, and now you have what amounts to an electric car. Right. That has been charged by virtue of the hydrogen through a fuel cell. Right. How does a fuel cell?
Well, I think I don't know. I'm not a scientist. I wasn't around for 100 years, but I'm kind of upset that they named it a fuel cell, because I try and tell my office, don't talk about this process and call it fuel. What we're doing is we're putting hydrogen gas on one side of a catalyst and air on the other side, and the hydrogen wants to mate with the oxygen and turn into water. It's attracted. There's an attraction there. It's physical. They get together.
Think of it that way.
When they
It's
do,
romance.
when they do, they give off heat and electricity.
Okay.
Just like you and your wife, heat and electricity. Okay, and that runs your battery, charges your batteries, or runs your motors. You take energy to pull the water apart. When the oxygen and the hydrogen get back together, they give you back some of that energy. So there's a loss. That's why it's not completely efficient, that you get a lot of energy back out of your hydrogen oxygen electrolyzer or fuel cell, but you do get energy back, and it's substantial enough to charge batteries and run motors.
Okay.
So I tell my folks, we're not using it as a fuel, we're not burning it, we're basically just putting it back together to make water. So your only byproduct is heat and water with the electricity.
And both of these processes were probably invented in 1812.
You're exactly right. That's over 100 years ago.
Isn't it amazing the way science works, you know, and we haven't really thought of anything better in all those years, but it works.
This technology has been proven by the Navy and submarines. It's been proven by NASA and spacecraft. This is, I almost want to say it's not high tech anymore. It's very old technology. We have just not found it efficient compared to gasoline. Gasoline is always an oil, been cheap for a long time. Now we have a lot of people that want to do liquid natural gas or something to bring our energy costs down, and that's okay. It's probably a really good bridge. But if you're doing liquid natural gas, you're just doing a little bit more efficient, but you're still burning carbon-based fuels, and eventually they're going to be expensive, because when you start having the worldwide demand and we're able to export it, you're going to see those prices go up. So if you're looking for a long-term solution, I see the price of hydrogen getting cheaper and cheaper and cheaper, and the price of fossil fuels getting more and more and more. So I think to go back to your original question of, are we going to have a lot of hydrogen vehicles versus internal combustion vehicles? At some point, I think we're going to have a lot more hydrogen vehicles and a lot less internal combustion vehicles. And the internal combustion vehicles you see will be hybrids. And the hybrid is nice because it's basically an electric vehicle that takes your gasoline and uses the most efficient combination of engine possible to generate electricity. Because so when you're in a hybrid car, you're not just running with the engine, you're not accelerating and decelerating with your engine, you're making electricity with a generator. And your motors are driving your car, and they're more efficient than internal combustion. So I'm into both. I'm into all electric vehicles. Fuel cell, hydrogen, hybrid.
One thing Stan didn't mention is if the climate change debate continues, and I think it will, at least we may need a few more storms to push some people over the line, but eventually I think there's going to be a fairly high tax on carbon that would make hydrogen, by comparison even with electrolysis, look very attractive on a cost-effectiveness basis. So I think it's just a matter of time, and I think what Stan and his folks are doing now is kind of proving the concept, getting it sorted out as to what's needed, where the problem areas are. How do you do this on a grand scale? They're learning how to do it on a small scale. In fact, what you're saying is that we don't even have manufacturers of fuel cell vehicles that are making it in great quantities. Right. Now you have to buy a regular vehicle and pull the engine out now to right. have even a test bed.
There's Alfred Yee. He's a local engineer, and he's working off the coast of India. There's a military island there.
Diego
Garcia, or near there, with a platform that creates hydrogen from OTEC energy. And so, I mean, there are lots of ways to skin this cat. And I guess the question is, moving from what you'd call a carbon economy, or a carbon fuel economy, to a hydrogen fuel economy would really change everything. And so you really got the tiger by the tail on this, Stan. So much so that I think we need to take a break.
I gotcha.
Okay, that's Stan Osserman. He's with the Hawaii Center for Advanced Transportation Technology, and my co-host Ray Starling from Hawaii Energy. We're talking about hydrogen for Hawaii. Here on Hawaii, the state of clean energy. When we get back from this break, I'd like to talk about how all this affects, interacts, enhances the grid.
Okay.
Okay?
Great.
You don't seem intimidated by that
Never.
question. Okay. We'll be right back.
I'm Hong Jiang, host for Asia in Review on Tuesdays.
And I'm David Day, host for Asian Review on Thursdays. Both of us broadcast our respective shows at 4 p.m.
And my topics tend to deal with questions related to environment, culture, history, and sometimes human rights.
And my shows tend to be on international business, foreign policy, geopolitics, and national security. And you can watch our shows live on the ThinkTech website at thinktechhawaii.com.
And you can also watch us on YouTube or Olalo.
So come join us on Thursdays at 4 p.m. I'm David Day.
And on Tuesdays at 4 p.m., I'm Hong Jiang.
Aloha.
Hello.
Okay, we're back. We're live. We're here on Wednesday in Hawaii, the state of clean energy. We're talking about hydrogen for Hawaii with Stan Osserman of HCAT, the Hawaii Center for Advanced Transportation Technology, my co-host Ray Starling. So the question before the House, should you care to accept the mission, Stan, is how do all these wonderful possibilities around hydrogen affect, or how could they affect the grid?
Okay, well, the folks that run any grid, whether it's HECO or HELCO or the grids on the mainland, they have a big challenge. We demand clean power when we turn on our computers and we turn on our TVs and all our electric appliances at home. And that's a tough job. Managing a grid is a really tough job. HECO has a tough job to do. But part of the solution could very well be hydrogen. A lot of the mainland utilities are taking what we call distributed generation and power on demand from hydrogen, stationary hydrogen fuel cells. Not fuel cells in a car, but fuel cells that are out in your grid in areas that have a high fluctuation.
Like a battery, so it works like a battery.
Exactly, because it responds very quickly. So they'll usually have a battery stationary fuel cell utility application out in the grid, and when it senses a drop in the photovoltaic production in a neighborhood because a cloud came over, it kicks in and pushes power into a smaller area, rather than HECO or that utility company having to go back and signal to make more power and have their transformers and their substations, try and catch up quickly on a big grid. So a lot of utilities are putting the smaller generation capacities out in their grid. When they have excess energy, they make some hydrogen, they store it, and then when they have these drops in production, the hydrogen fuel cell kicks in and puts power back in their grid.
So it's fast response, really fast
Yes.
response. And this is the fuel cell response. I guess you put the hydrogen in the fuel cell and you get electricity
Right.
very quickly.
Yeah.
So you don't need an actual battery between, or do you?
Well, most of for example, we have a stationary fuel cell at Hickam, and we asked for a battery with it for a quicker response and a little bit more controlled response, because the electric company, like I say, they have to balance smoothly. They're trying to make the grid smooth. So you have to have controllers and other things and a capability to ramp up at whatever pace you're dropping or adding. So, having batteries out there in the grid is also a good stabilizer, and I think it's good practice to put batteries with a stationary fuel cell to help you smooth out power on the grid.
Batteries don't have to be nearly as big if you have the
Correct.
fuel cell available to charge them up fast.
Correct.
Right?
Well, I was just going to say that's called distributed generation,
Generation.
and that's sort of new out there now. And I think the utility is becoming more fond of that because it does help you can actually help various circuits that have issues with them in terms of how much PV you've got on them and how much you can add. So it really sounds like there's a place for fuel cells as well. And I think that's generally believed that that it's not going to be any one technology that gets us where we want to be, and that's often fossil. It's going to be a whole lot of different technologies that come together.
Combined, but all integrated, working together.
Orchestrated.
You can do you can do that. I mean, he just described really what you can do to make it almost irrelevant, seamless, irrelevant as to what it is that's making the electrons, but they're being made locally. They can be controlled locally and go into the grid as needed.
Here's the thing, you know, the hydrogen in this sort of double deal with, you know, the fuel cell plus the battery to give you a really smooth curve. The hydrogen could come from anywhere in the state without any need for an undersea cable.
Right, you make it on site.
You make it on site, and you know, send me 20 bottles of hydrogen tomorrow. You know, and it goes on the barge or whatever, and so or on the ferry. If we were really enlightened, we'd put it on the ferry. But we could move this around and have it, you know, on demand so that it could be used anywhere in the state, and therefore it could supplement the grid anywhere in any island. Indeed, distributed.
Jay, we might even be able to export it to other countries and the mainland.
Okay, we got 2 minutes to talk about that. But what do you mean? How does that work?
Well, like Department of Energy asked a question on one of their, you know, Stump the Dummy websites someplace, and they asked the question, how much excess electricity is made, or how much electricity would have to be generated by sunlight to power the entire world? If you had to power the entire world for a day, how long would the sun have to shine on the entire world to do it? And you know, the answers were like 11 hours, 4 hours, 6 hours, 2 hours. It's like 11 seconds. Hawaii itself, between ocean geothermal, wind, regular geothermal off of the hot spots that we have, even on this island, photovoltaic, we can probably produce more energy both for the grid and for our transportation than we need. And so if we can produce it and export it, it's now an export. So we could potentially, if we do it right, the technology comes along with us, we could potentially be exporting energy rather than importing it. And you know what that ratio looks like now. We're importing an awful lot of energy.
So let me get this straight. We invent the practices that lead to a global standard of tank and fittings for the tank, sort of like the charging nozzle on an electric car, you know?
Right.
It gets standardized, okay? And we sell it. We go to Asia and we sell it. And now there's a world market, okay, that can be satisfied and transported through that standard. And then we get to export these bottles, standard bottles, however big they are, of hydrogen, and we actually get paid for that. And we all sit around like on the, you know, the Nauru Island situation, right? And we all get checks in the mail from the government.
There you go.
For, you know, and
or Alaska.
Or we get rich, all of us, because we are exporting energy when in the past we spent all our disposable income buying it.
Keep dreaming, Jay. Keep dreaming. We're not going to. I don't know if the government's going to give us any money, but
you know, we could do something like that, don't you think?
I think so. And I just realized, you know, we send those transport ships that bring us all the goods and stuff that we have.
Two-way trip.
Yeah, it goes back. It's full of hydrogen
it's the Bermuda
from Hawaii.
Triangle.
Of people wanting a container of Hawaii hydrogen.
Hey, we could have special Hawaii hydrogen.
The brand name.
It's almost
little
like
logo on the
there
front.
You go.
This is pure hydrogen.
Hydrogen with aloha.
From renewables.
There you go.
There you go.
Hawaiian,
you heard it here.
With Hawaiian sunshine. Made with Hawaiian sunshine.
There you go.
There you go.
All right.
This is a classic show, actually.
I hope so.
But I'm gonna let Ray summarize now. Ray?
Well, we appreciate your coming and enlightening us. Actually, I thought I knew a lot about fuel cells and hydrogen, and you just enlightened me a lot more, and I'm sure you did with our viewers. I'm looking forward to seeing you expand what you're doing, and I think, you know, especially on the Big Island, you got to start there with a bus that's actually going to be in real service there, and I think that's going to help the whole process of getting to the clean energy future that we want. So hope you'll come back again.
I will.
as things evolve, and let us know what's happening.
We'll update you. And it's exciting. It's an exciting time to be doing what we're doing, and I'm excited about what we do.
Yeah, I absolutely agree, and I know Jay does.
When you do this and you get to be a world figure, I hope you'll still talk to us.
He's already a world figure.
Okay. Thank you,
I will
Stan.
always remember you, Jay, fondly.
Stan Osserman, Hawaii Center for Advanced Transportation Technology, and it's great to talk to him. Ray Starling, my co-host from Hawaii Energy. This was Hydrogen for Hawaii on Wednesday, Hawaii, the State of Clean Energy. Thanks for watching. We'll see you tomorrow. We have Urban Transcendence beginning the lineup at 1 o'clock tomorrow, Thursday. Aloha.
Thank you.